Greetings everybody. This is the last or next to last video for the first practice test for Exam 1. And it's problem 6 on the practice test. And we want to show that all geosynchronous satellites orbit the Earth at the same height of 3.59 times 10 to the 7th meters. So it's a UCM problem involving a geosynchronous satellite. Let's go ahead and sketch it. And here's the geosynchronous satellite. It's orbiting the Earth, so the satellite itself is undergoing UCM. The circular orbit is indicated by the dotted circle. It has a radius of r in the red. Here we see RE is the radius of the Earth. H is the height of the geosynchronous satellite. Remember, that's the height above the surface of the Earth. That's the radial force acting on the satellite, given by Newton's universal law of gravitation. Well, we have these following values put in the box down here. The fact that, the gravitational constant G, you've got here the mass of the Earth, you've got here the radius of the Earth, and you've got the period of the satellite's orbit. Remember, geosynchronous means its orbit, the period of its orbit is the same as the period of the Earth's rotation about its axis, 1 day. All right. So the force on the satellite, this radial force, is given by the universal law of gravitation. That F is G, mass Earth, mass satellite over r squared. So that's the radial force. So Newton's second law for UCM states that radial force is equal to mv squared over r. But the m is the mass of the satellite, because the satellite is what's undergoing the UCM. So you have G, so on the left, what is the force, which is G me ms over r squared. That's equal to ms v squared over r. Now we want to solve this equation. We want to solve for r, because eventually, if we know r and we know re, we can get h. So we want to first solve for small r. Well, if you take this equation and do the algebra, you're going to get r is equal to g me over v squared. Now remember, what is v squared? We know this from one of the previous lectures. V squared, remember, it's UCM. V is 2 pi r over large T. Remember, v is 2 pi r over T. So v squared is 4 pi squared r squared over T squared. So I need to put this equation in for v squared. See, v squared is in the purple. Right here, I'm going to replace v squared with 4 pi squared r squared over T squared. Once I'm going to do that, then I want to solve for r, or in this case, r cubed. So again, nothing complicated. If I take this expression for v squared, plug it in the denominator, then solve for r, or r cubed, you get this. You get r cubed is equal to g me t squared over 4 pi squared. Well, r is simply the cube root of that. R is simply the cube root of g me t squared over 4 pi squared. Well, what are g, me, and t? Right over here in this table. Remember MKS. T is the 8.64 times 10 to the 4 seconds. G is the 6.67 times 10 to the minus 11 Newton meter squared per kilogram squared. Mass of the Earth, the 4.97 times 10 to the 24 kilograms. So plug those values in. You'll get a value for r. Then what is h? Well, h is simply equal to r, whatever you get for r, whatever number you get here, you then subtract off re, and you'll get 3.58 times 10 to the 7th meters. I guarantee you. So work through the algebra. What we're saying is the centripetal force, F, is given by the universal law of gravitation. Okay? G me ms over r squared. Well, applying Newton's second law for UCM, that radial force, that centripetal force, is mv squared over r. Okay? Solve for r, okay, and you get this first equation. But notice you got that v squared in the denominator. What do you do with that? Replace v squared with this, 4 pi squared r squared over t squared. So take that expression, put it in for v squared, then you should end up with r cubed is equal to this, which means r is simply the cube root. Plug in the numbers, get a value for r. Then once you get a value for r, how do you get h? H is just little r minus radius of the earth. And you should get it. So let me go ahead and solve this video. And really it's just we're saying that this radial force, this centripetal force, is G MEMS over r squared. Well, the sum, Newton's second law for UCM, the sum of the radial forces, of which there's just the one, is equal to m v squared over r, where it's the mass of the satellite, because the satellite is what's undergoing the UCM. Then follow the steps. First step, solve for r, but then you've got this v squared. Well, you're going to then substitute in this expression for v squared, and then you should end up with r cubed equals this expression. I mean, r is the cube root. Plug in the values, then you get your number for r, and then subtract off re, and you'll get the answer that you should. Let me go ahead and stop this video and post it.